Welcome back to our lecture. So in the previous section, I talked about a few different container orchestration platforms. And the orchestration platform that we use in this course is AWS ECS. And if you recall, there's sort of two different ways we can deploy containers in ECS. One option is to allow ECS to spin up managed EC2 instances. And these instances are running an agent. We can deploy containers on these instances, and they're sort of fully managed by ECS for us. The advantage there is that we can also shell into the EC2 instances. The other option is to deploy containers into Fargate. And Fargate essentially is a compute environment, compute resources, which are completely managed by AWS. We don't have the opportunity to log into those instances. They're fully managed. And so when we run containers in Fargate, we can essentially treat containers like a fundamental compute primitive, meaning that we can launch and manage our containers in Fargate like they're almost like EC2 instances. And so it's fully managed infrastructure provided by AWS. And this happens to be the default way of running containers now in ECS. So originally, when ECS was launched, you had to launch your containers into EC2 instances. But more recently, at least at the time of this video recording, Fargate was announced, and now Fargate represents the default infrastructure for ECS. And one of the other nice things about Fargate is that it integrates really nicely with a number of other AWS services like VPCs, application load balancers, CloudWatch, and of course you can use CloudFormation to build out your cluster and containers in Fargate. Fargate consists of a number of components, and it can be a little bit challenging to understand at first because there are multiple layers of abstraction which are used to manage containers running inside of Fargate. And this is kind of a pretty common practice for container orchestration platforms where you have these multiple levels of abstraction. And the benefit of these abstraction layers is that it provides us with greater flexibility, and it allows us to sort of build more complex application platforms. So Fargate consists of multiple different layers. You can think of them as being sort of layers in an onion. And starting with the outermost layer, we have a cluster. A cluster is where we're hosting all of our containers. A cluster, inside of a cluster, you will find one or more services. And as we'll see, a service is used to define exactly like how we're going to deploy our containers. The service controls sort of like the scheduling of containers in terms of how many containers are going to run within the cluster and so on. Each service will have at least one or more task definitions. And a task definition, part of a task definition is a container definition. So when we create what we use a task definition for is to create tasks that are running within the cluster. And a task can consist of one or more different containers. So if this sounds a little bit confusing at first, then just bear with me a while because I'll walk through each one of these components in more detail. And then it might not really start clicking until we actually look at CloudFormation code and actually start launching services into the cluster. And hopefully then things will kind of begin to make more sense to you. Here's a diagram kind of showing how some of these pieces fit together. On the left-hand side, we have a service that we have defined. The service has a service description or definition. And then within a service, you'll find one or more task definitions. And we take this service and we deploy the service to Amazon ECS. It will then place the tasks that are defined by the service into the cluster. And in this case, it's deploying them into Fargate. Each task that is running within Fargate will be given an elastic network interface, an ENI. And we'll see that actually these tasks are running within a VPC, so they are afforded all of the same capabilities as other resources running in VPCs, like they have security groups and they'll be part of a subnet and so on. Okay, well, let's start looking at each one of these components in more detail, starting from the outside and then going in. We start by looking at creating a cluster. How do we do that? Well, a cluster really represents a group of one or more services running within Fargate. And when we define a cluster, we're basically just giving it a name. It's kind of like a namespace in the sense that it's just a kind of a grouping mechanism to group together a set of services. And here you see some very simple CloudFormation template code to create a cluster. The next component is a service, and there's a lot going on in a service. So there's a number of different service properties that we'll take a look at. The service definition that we create is going to describe a number of different things. The type of hosting infrastructure we're going to use, whether we're going to use Fargate or the traditional EC2 instances. In this course, we'll focus on using Fargate. We'll specify the VPC subnets that our tasks or our containers are going to be running in, and the security group that the tasks that are associated with the service will use. So we can use security groups the same way as we do with things like EC2 instances and load balancers and NAT gateways, etc. We specify how many tasks we want to run simultaneously. We could have a service which has one task defined. It could be like a web server task. And that web server task is using, say, like the Nginx Docker image. Well, the service could specify that we want to run 3 of those tasks within the cluster. So that's controlled by, that sort of scheduling mechanism is controlled by the service. The service will also determine how those tasks get deployed within the cluster. And we can leverage a couple different deployment types. We can do rolling updates of tasks within the cluster. We can do blue-green deployments in the cluster. We can even create our own sort of external custom deployment mechanism just simply by exercising the AWS API. The service also allows us to connect our tasks, our containers, to an external application load balancer. We can use load balancers to distribute traffic to containers running within a Fargate cluster, just like we're distributing traffic to a set of EC2 instances. And then finally, we can leverage a service discovery mechanism. We can use something like AWS Cloud Map as a service discovery mechanism within the cluster as well. And we'll see an example of that later in the lecture. I mentioned that we can use load balancing to distribute requests across our tasks. The one thing to note is that when you define a task, you can actually specify multiple containers that are a part of that task. When you have a single task definition, all of the containers that are defined by that task definition are going to be placed on the same physical host within the cluster. Now, if you have a service that you define, like that Nginx task I was talking about earlier, and you say, I want to run 3 of those tasks within the cluster, and you configure the service to run on multiple subnets and multiple availability zones, then Fargate will actually try to deploy your containers across multiple availability zones on separate hosts for greater resiliency. In terms of how does the load balancer connect to the containers? Well, the load balancer connects to the containers via the Elastic Network Interface, that IP address which is assigned to each of the containers in the cluster. So it's very similar in many ways to our traditional EC2 instances. Our containers will have private IPs. We can optionally configure the containers to get public IPs as well. So we can treat them as like first-class components, just like our EC2 instances. We can leverage auto-scaling as well as part of the service. So the ECS service can automatically scale the number of containers that we're running in the cluster. That can scale our tasks up or down based upon a minimum number of desired tasks that we specify, or we can set up a policy based on CloudWatch metrics to automatically scale tasks. So we could scale tasks based on the platform demand. And then, as I mentioned, we can leverage service discovery, where we can leverage something like AWS Cloud Map for service discovery within the cluster. Here's an example of a CloudFormation resource definition for an ECS service. You can see that we're referencing the cluster in the service definition. So we've defined the cluster earlier in the template. The desired count is 3. So we're specifying that any of the tasks associated with the service, we want 3 of those tasks running. We have a launch type of Fargate, meaning that we want to use the managed Fargate compute environment to host our containers. We have a task definition, which we'll look at shortly. This is what actually defines the containers that are going to be running as part of this service. The network configuration, we have the option to assign a public IP, which here is enabled. We can also define security groups and subnets that the service can utilize. And ECS will try to deploy our containers across one or more subnets that we define, and then it'll associate these containers with a one or more security groups. And then finally, we have a section where we are associating the tasks in this service with a load balancer. And you can see we have a target group ARN defined for the load balancer. and distribute requests to the containers that are specified as part of the task. Okay, well then the sort of the last piece is creating the task definition. And the task definition is really focused on describing how we're going to actually run the containers within the cluster. The task definition has a property called the family, and that's basically just a name that we are assigning to the task definition. We have a network mode that our containers are going to use, and when we use Fargate, we use a special networking mode called AWS VPC, which basically means that all of our Fargate-based containers are going to be running within a VPC, and they'll each have a dedicated Elastic Network interface. Here's where we define how much CPU and memory we want to allocate to a particular task. And we can also define an IAM role. And this operates just like an EC2 instance role, where if we have an application running within a container and that application needs to be able to access other AWS resources, it can do so using the credentials and the privileges granted via an IAM role. A big part of the task definition is the actual container definition. And the container definition will describe one or more containers that we want to run as part of this task. So here's where we're specifying the Docker image that we want to use and where we're going to pull it from, the amount of CPU memory to allocate to the container, a logging configuration. So by sort of default, we use the AWS logs driver, which will send all of the log output information from the containers and forward those logs to AWS CloudWatch logs. We can specify a command that the container will run when it starts up, and we can, and these containers have access to some storage within Fargate, which is kind of nice. There's 10 gigs of ephemeral Docker storage that's available to our containers. And there's 4 gigs of what we call volume mount storage that the containers within a task can share. And the key thing here to remember is that you should consider this storage to be ephemeral. You should never store data within the container or within the Fargate cluster. You should always persist data outside of it in something like S3 or DynamoDB or maybe like an RDS database. Here's an example of how you might create a task definition in CloudFormation. And so here you see we have a container definition, and we are defining basically the 2/3 of this is really defining how the container is going to run. So you've got the command that's going to be used. You have an entry point you can define, an image, which in this case is an Apache Docker image, HTTPD version 2.4, the log configuration using the AWS logs driver. We have port mappings that we can define. We can map the port 80, which is being exposed by the container, to port 80 on the host. We are allocating a certain amount of CPU and memory. There's an execution role ARN. That's the execution role which is associated with our containers. That's sort of like the instance role that's associated with the container. And of course, the network mode, if we're using Fargate, the network mode is always going to be AWS VPC.